This is lesson number 13, Algebraic Proofs. The essential question is, how can algebraic properties help you solve an equation? Scholars will use algebraic properties of equality to justify the steps in solving an equation, use the distributive property to justify the steps in solving an equation, and use properties of equality involving segments, lengths, and angle measures. So, what is an algebraic proof? An algebraic proof is a proof that is made up of a series of algebraic statements. The properties of equality provide justification for many statements in algebraic proofs. Your card number 16 is the algebraic properties of equality. So let's take a look. The algebraic properties of equalities is card number 16. On this card, you have 9 different properties. You will probably need to use the front and back of the card. That is perfectly fine with me. Let's go quickly through the algebraic properties of equality. The addition property of equality says that if A is equal to B, then A plus C is equal to B plus C. So basically, if you add something on one side, you have to add it on the other. The same thing holds true for the subtraction property of equality, the multiplication property of equality, and the division property of equality. If you add, subtract, multiply, or divide on one side of the equation, then you must do the same thing on the other side if A is equal to B. And please also note that all of these properties are true for any real number when we use the letters A, B, and C. So we are talking about any real number. So after your multiplication, after your addition, subtraction, multiplication, and division properties, then we get into properties that we have perhaps seen before, but have never used them or really even needed to use them. So let's take a look at them right now. So we are going to start with the reflexive property. The reflexive property is probably the one that you kind of think is pointless, but we definitely need it. The reflexive property says that A is equal to A. The symmetric property of equality says that if A is equal to B, then B is equal to A. So essentially, order does not matter. The transitive property of equality says that if A is equal to B and B is equal to C, then A is equal to C. The substitution property of equality says that if A is equal to B, then A may be replaced by B in any equation or expression. So you can replace A with B in any equation or expression. And then the last one, which is the one that you've probably seen the most and are most familiar with, of course, is the distributive property, which says that A times the sum of B plus C is equal to A times B plus A times C. So you will distribute the value on the outside. So these are all the properties that we are going to use as we look at our algebraic proofs. So example number 1 says, how do you justify each step when solving equations? So obviously we are going to be solving equations. So here is our original equation. It says that 2 times the difference between 5 and 3a minus 4 times the sum of a and 7 equals 92. And this is our original equation. So of course, in order to solve this equation, then the first thing that we would do is we would distribute. So that's going to be the 2 times 5, 2 times 3a, negative 4 times a, negative 4 times 7. So our next step would be 10 minus 6a, so that's the distribution, minus 4a minus 28 is equal to 92. And what allowed us to do that was the distributive property. So that is the property that you see on the right. Then after that, what do we need to do? We need to put together our like terms. So then the next line we have is negative 18 minus 10a is equal to 92. And our property was substitution property. Well, how does that make sense? We haven't changed anything. We haven't moved anything. We definitely have. If we have a positive 10 and a negative 28, that is negative 18. So I may substitute the value of 10 minus 28 to be negative 18. Likewise, if I have a negative 6a and a negative 4a, I may substitute negative 10a because negative 6a minus 4a is a, negative 10a is b. And so if a is equal to b, then I can substitute b for a. And so that's exactly what I've done in this case. So next I have negative 18 minus 10a plus 18 is equal to 92 plus 18. And so this is going to be the addition property. How is this the addition property? Because I have added 18 on both sides. So that makes this the addition property. Then I'm going to do the actual math. So that means I'm going to go back to my same colors. Negative 18 and a positive 18. That's going to give me 0. And then I'm going to do 92 and 18, which is going to give me 110. So I'd be left with negative 10a is equal to 110. And so if I'm solving this equation, then I know my next step is I'm going to divide both sides by negative 10. That's going to be the division property, me dividing both sides by negative 10. And then when I simplify that again is going to become the substitution property, because negative 10 divided by negative 10 gives me 1a or just a, and 110 divided by negative 10 is negative 11. So I'm substituting their new values when I simplify an equation. So here you have all the steps to solve an equation, which you already know how to do. Now you have to include the properties that you would use in order to justify those steps.